So compounds are composed of atoms that are held together. What's holding them together? It's the chemical bonds. Chemical bonds come from the attractions between charged particles. We learned that there are electrons with negative charges and protons with positive charges in atoms. So a chemical bond results from the attractions of these charged particles. And we can break chemical bonds into two broad categories, ionic and covalent. So in ionic bonds, this involves the transfer of electrons from one atom to another. When the electrons are transferred, the atom turns into an ion. It has a charge. This is going to happen between metals and nonmetals. We learned that metals tend to lose electrons and form positively charged cations. Nonmetals form negative ions by gaining electrons. So a metal and a nonmetal can get together. The metal gives electrons to the nonmetal, and the result is two oppositely charged particles. These oppositely charged particles then are attracted to each other because opposite charges attract. So it's electrostatic attractions between these ionic, between the ions. In the solid phase of an ionic compound, these particles are arranged in a regular three-dimensional pattern. There are a lot of variations of those patterns, but the cations and anions will be alternating to maximize the attraction between opposite charges and minimize repulsion between like charges. As an example, here we've got sodium metal and chlorine gas. Sodium metal is composed of individual atoms of sodium. Chlorine gas forms these molecules with two chlorine atoms. And what happens in a reaction to form sodium chloride is the neutral sodium atom with 11 electrons gives 1 electron to the chlorine atom. Chlorine atom has 17 electrons. As a result, we have a sodium ion, 10 electrons, a chlorine ion with 18 electrons. This has a positive 1 charge because the number of protons didn't change. This has a negative 1 charge because we now have an extra electron. These oppositely charged particles are attracted to each other, much like magnets stick together. So you can imagine one of those magnetic building toys. You have the magnetic pieces and they just like click together and they want to be together, right? That's what ions do. The properties of the ionic compound are extremely different from the individual elements.
So a compound can't be formed by 2 cations?
A compound cannot be formed by 2 cations, that's correct. Because 2 cations have like charges and they will repel each other. You can form mixtures of solid metals, but they're not actually compounds. Metals don't really form compounds with each other. They form what are called alloys. Any other questions? The other type of bond is called a covalent bond. And this prefix co refers to sharing, right? Covalent bonds occur between 2 or more nonmetals. So we just mentioned that you can't have a compound between 2 cations. You also can't have a compound between 2 anions because opposite charges repel. They're not going to want to be next to each other. With nonmetals, they both want to become negative ions, but nobody's willing to give up electrons and become the positive ion. So what they do instead of transferring electrons is they share their electrons. So the electrons are shared. There's no electron transfer. The covalently bound atoms together, and it could be 2 or more, compose a molecule. Each molecule is independent. And so because these compounds contain molecules, we call them molecular compounds, as opposed to ionic compounds that have ions. So how does the electron sharing work? At a very simple level, we can think of this as the electron, and these are the nuclei of the 2 atoms. The electron is attracted to both of these nuclei, And when it's directly in between the two nuclei, that will be the lowest energy state, the most stable, because we have maximum attraction with each. If we pull the electron out here or pull it over here, that's going to be a higher energy state. So the shared electron between the two atoms is what holds them together. Any questions?